Hello friends, in today's question, a student is performing an experiment using a resonance column and a tuning fork of frequency 244 per second. He is told that the air in the tube has been replaced by another gas. Assume that the column remains filled with the gas. If the minimum height at which the resonance occurs is 0.35 plus minus 0.005 meters, the gas in the tube is, and there is certain information that is given to us which we are going to use in the solution. We are given 1.167 RT square root as 640. Similarly, we are given 140 RT as 590 joule, and the molar mass M is in grams given in the options. So we have to find out the which of the gas is present with respect to the neon having a molar mass of 20, and there are certain values that are associated with each gas is given to us. So we are going to start this question by saying that let the L be the length of the resonance column. So we say length of resonance column is our L, and wavelength is our lambda, and velocity is v, and finally the frequency is represented as f. So therefore we can write the relationship between all these four variables. We can write that our length L will be equal to lambda by 4, which gives that our lambda will be equal to 4 times L, and our velocity is equal to lambda multiplied by frequency. And if we substitute value of lambda in this equation, we get our velocity will be equal to 4 times L multiplied by frequency. And we know the value of f, which is our 244, and value of 4. So from here we can write our velocity v will be equal to 244 multiplied by 4 multiplied by L. And let us call this as equation number 1. And L is given to us as L is equal to, we have here 0.350 plus 0.05 meters, and this comes as, rather we can say it is plus minus. So first we are going to find out for plus, then we are going to for it minus, and this comes as 0.355 meters. And under this condition we get the value of velocity will be equal to 244 multiplied by 4 multiplied by 0.355, and this gives us the velocity will be equal to 346.5 per meters. Similarly, we are going to take value of L as 0.350 minus 0.005, and this gives us 0.345. Therefore we have that a velocity will be equal to 244 multiplied by 4 and multiplied by 0.345, and this gives us the velocity as 336.5 meter per meter. So this value of velocity we have given it as 4 gases: neon, nitrogen, oxygen, argon. and we are going to find out what will be the value of velocity for each of the gas, and then we are going to make the comparison between these two values, and these two range values of the velocity will help us in identifying what type of gas will be present in the tube. And we already know the relationship. The velocity of sound wave is given as velocity of sound wave, that is v, it is given as square root of gamma p divided by rho, and we are going to slightly modify this equation. We can write p is equal to gamma p v divided by m, and it can be further written as, by using ideal gas equation, pv is equal to nRT. So we can write that our velocity will be equal to gamma RT divided by m. Here m is the molar mass of the gas in the gram. M is the molar mass of gas, and that is in grams. And we have to do this modification because of the relationship value which are given to us, that is 167 RT and 140 RT, and also with respect to the molar mass of each of gas and the values that are associated with each gas. So let us further modify it, and we can write that our velocity v will be equal to gamma RT, and we can write this as m into 10 to the power minus 3, and this is simple conversion into our kilograms, which can be further written as 1000. We have gamma RT divided by m and square root of this entire thing, and we can further write it by using a slight modification, because we have to modify this equation, that the velocity equation, according to the formula that is given to us in the question. So we can write this as velocity will be equal to this, we can write 100 gamma RT and its square root multiplied by 10 and divided by m. And the gases which are given to us, so from the standard, you can say the standard which are known to us, we already know that neon and argon are monatomic. So we can write here as neon and argon both are monatomic, and oxygen and nitrogen are diatomic. Oxygen and nitrogen, these both are diatomic, and therefore we are going to have two different values of gamma. For monatomic, we can write our gamma will be equal to 1.67, and for diatomic we can write our gamma will be equal to 1.4. Therefore we get that velocity of gas in the neon, so we can write this as V neon will be equal to 100 into 1.67 multiplied by RT, and this multiplied by 10 by 20. This gives us that V neon will be equal to 167 RT square root, and this is multiplied by 10/20, and 167 RT we are given to us as 640. So this can be written as 640 multiplied by 7 by 10, and this gives us 448 per second. Similarly, we are going to find out V argon, that's the velocity when we are going to use argon gas, and similarly we are going to get this as 167 RT square root, and this will be about 10 upon 36 and its square root. So we get this as 340, sorry, this is meter per second, meter per second. 1 second. Sorry, here also I have written per meter. This should be meter per second, and here also. Yeah, let's look. Okay. Next is our velocity of oxygen, and velocity of oxygen we are going to write it as 100 multiplied by value is 1.4, and we have this as RT square root, and we have this 10 by 32. So this becomes as 140 times RT square root, and we have this as 10 by 32, and this gives us the velocity of the oxygen is our 331.8. 331.8 meter per second. And we are left with our only one gas, that is our nitrogen now. So we can write velocity of nitrogen will be equal to 140 RT square root multiplied by 10 by 28, and this comes as 354 meter per second. And according to the velocity which we calculated, it has the velocity should be lying between the range of 346 and 336, and this is only possible for our argon gas. So we can say that velocity of argon is greater than 336.5 but less than 346.5, because velocity of argon is our 331.8. Sorry, velocity, my mistake, 1 second. Velocity of argon is 340. So therefore you can say the gas is argon, and the option that will be correct one will be option number D is the correct option. Option D is correct. So this completes the question. Thank you.